the last method to obtain an approximate solution to the given differential equation having first order and first degree. Up to this lecture we have finished three important methods, that is Taylor series method, Picard's method, Euler method and modified Euler method to obtain an approximate solution to the given differential equation. Now again there is one more efficient method as compared to previous three methods, and it is very simple to calculate and to use in computer algorithm and computer program also. So it is named as Runge-Kutta method. Again, this method has two parts: second order and fourth order. Fourth order Runge-Kutta method and second order Runge-Kutta method. So, if dy by dx is equal to f of x1 is the given differential equation having initial condition y of x0 is equal to y0, then by using Euler series formula we can find y1 is equal to y0 plus h f of x0 y0. This is the formula for Euler method, and on this formula, on this formula if you apply the trapezoidal rule, then this formula can be written as y1 is equal to y0 plus h by 2 f of x0 y0 plus f of x1 y1. ओके, हा फॉर्म्युला कसा आला तुम्ही मॉडिफाय युलर फॉर्म्युल्यानुसार पाहू शकता बघा. तिथे मी एक्सप्लेन केले की दिस इज आल्सो मॉडिफाय युलर फॉर्म्युला आपण या फॉर्म्युल्यावरच डेव्हलप केला आहे. ओके, सो दिस इज व्हॉट y1. दिस कॅन बी रिटन ॲज if we put value of y1 is equal to y0 plus h f of x0 y0, then y1 is equal to y0 plus h by 2 f of x0 y0 plus f of x1 y1 is equal to y0 plus h f of x0 y0. And if we write here, if we multiply this h inside the bracket and if we write f of x0 y0 is equal to f0, just this is only notation, then what is the value of y1? Y1 is equal to y0 plus 1 by 2 h f of 0 plus h f of, if we multiply h here, f of x1 y0 plus h f of 0. Okay, so up to this is Euler formula. We apply the trapezoidal rule, and here we put, in place of y1 we put the value obtained from Euler formula. Okay, and then in next step we multiply by h, and instead of writing f of x0 y0 we denote this term as f0. Okay, now so if k1 is equal to h f of 0, if we put k1 is equal to h f of 0, then and k2 is equal to h f of x1 plus y0 plus k1, then what is the value of y1? y1 is equal to y0 plus 1 by 2 k1 plus k2. So this is called a second order Runge-Kutta method. This is called second order Runge-Kutta formula, where what is k1? k1 is equal to h f of 0 and k2 is equal to h f of, what is x0? x1 is what? x0 plus h and y0 plus k1. So by using this formula you can find an approximate solution of the given differential equation with second order. Okay, similarly for fourth order, we use the formula y1 is equal to y0 plus 1 by 6 k1 plus twice k2 plus twice k3 plus k4. Okay, inside the bracket twice k1 plus twice k2 plus k1 plus twice k2 plus twice k3 plus k4, where by using this formula we can find the value of y1. y0 is the given value, where k1 is equal to h upon x0 y0, k2 is equal to h f of x0 plus h by 2, y0 plus k1 by 2, k3 is equal to h upon x0 plus h by 2, y0 plus k2 by 2, and k4 is equal to h f of x0 plus h, y0 plus k3. So by using this formula, similarly you can develop this formula, and by using this formula we can evaluate the fourth order approximation. By using the fourth order approximation, we can evaluate the value of y1 at x1. Okay, so for an example, consider an example. By using Runge-Kutta method, second order method, evaluate y of 0.1 and 0.2 where correct up to 4 decimal places, dy by dx, where dy by dx is equal to y minus x, y plus x, y0 equal to 1 and h is equal to 0.1. Okay, so this many information is given. By using this information, we want to evaluate y of 0.1 and y of 0.2. Means how many iterations we have to perform. For first iteration, when we do the first iteration, we will get the value of y of 0.1. Okay, and when we do the second iteration, we will get the value of y of 0.2. So we have to perform 2 iterations to obtain y of 0.1 and y of 0.2, because what is h? H is 0.1. The iteration depend on values of h. If your h is 0.5, then you have to evaluate the 4 iterations, 0.05. Okay, 4 iterations. Then first 0.05, then 0.1, 1.5, then last 0.2. Okay, so here h is 0.1, and therefore first what is given here? How many terms are given? F of xy is equal to y minus x, y plus x. Then x0. This is the x0, where this term is x0, which is 0. y0 1. H is 0.1. Okay. So what is x1? x1 is equal to x0 plus h. 0 plus 0.1 which is equal to 0.1. So y0 at x0. So y1 gives a value at x1. That is what we want to determine, y of 0.1. So what is y1? By the second order Runge-Kutta method, y0 plus 1 by 2 k1 plus k2. Very simple. This is the formula for Runge-Kutta second order method. So here k1 is equal to h f of x0 y0. So h is 0.1, f of x0 is 0, y0 is 1. So it is equal to, and what is f of xy? It is y minus x divided by y plus x. So 0.1 inside the bracket, y minus x, 1 minus 0 divided by y plus x, 1 plus 0. So if we evaluate this, it is 1 divided by 1 is 1, so 0.1. So k1 is 0.1. Now what is k2? K2 is equal to h f of x0 plus h and y0 plus k1. So k2 is equal to 0.1 f of x0 plus h. Here we have obtained the value of x0 plus h. It is nothing but the x1. So x1 is what? 0.1 and y0 plus k1. Y0 is 1 plus k1, 0.1. So it is 1.1. 1.1. And if we evaluate this value, it is 0.1 inside the bracket. Inside the bracket, y minus x means what? 1.1 minus 0.1 divided by 1.1 plus 0.1. So this is equal to 0.1 into 1 divided by 1.2. So if you evaluate this, you will get it is equal to 0.0833. So what is K2? K2 is equal to 0.0833. Since we want to answer correct up to 4 decimal places, so this is what? K2. So here is the value of K2, here is the value of K1. Put these two values in place of in this formula, you will get the value of y1. So y1 is equal to, I am writing here, y1 is equal to y0. Y0 is 1 plus 1 by 2 inside the bracket k1 0.1 plus k2 0.0833. And if we do this calculation, you will get the value of y1 is equal to 1.0917. 0917. So this is the value of y of 0.1. Y of 0.1. So what is answer here? Answer, y of 0.1 is equal to 1.0917. Now to perform next iteration, here next we want to determine y of 0.2. There are again two methods. Either you can say this is directly x0, y0 and again apply the same process, or you can create a formula for y2. Okay, so here I am seeing again x0 is equal to 0.1, y0 is equal to 1.0917. Okay, then next, what is x1? x1 is equal to x0 plus h, so it is 0.2. Okay, then next f of xy is equal to y minus x divided by y plus x. Then what is k1? K1 is equal to h f of x0 y0, so it is equal to 0.1 into f of x0. x0 is what? 0.1 into y and y0 1.0917. So this is one method. You can say this is x0 y0 and again the same process. Okay, or other second technique is what? You can create a formula for y2 and then evaluate. Okay, so but I am writing here this is x0, this is y0, so process is same. So now if you evaluate this, you will get the value of k1. K1 is equal to 1.0917 0.0832. This is the value of K1. If we do this calculation, how to evaluate this? It is equal to 0.1 y minus x. So 1 minus 1.0917 minus 0.1 divided by 1.0917 plus 0.1. If we do this calculation, you will get the value of K1. Similarly, what is K2? It is h f of x0 plus h, y0 plus K1. So K2 is equal to h is 0.1 f of x0 plus h means what x1. So what is x1 now? 0.2 and y0 plus K1. So what is y0 now? 1.0917 plus K1. K1 is what? 0.0832. If we find this, it is equal to 1.1749. So if we evaluate this, you will get K2 is equal to 0.1. What is f of x1? It is y minus x divided by y plus x. So it is 1.1749 minus 0.2 divided by 1.1749 plus 0.2. So if we use calculator to do this calculation, you will get K2 is equal to 0.0701. Okay, so this is the value of K2, K1. So what is the formula of y1? Y1 is equal to y0 plus 1 by 2 K1 plus K2. So if we find this value, y1 is equal to y0. What is y0? Y0 is 1.0917 plus 1 by 2. This is the value of K1, 0.0832 plus K2, 0.0701. So if you do this calculation, you will get value of y1 is equal to 1.161683. So this is the value of y1 at x1 is what? 0.2, or you can write this as y of 0.2 is equal to 1.1683. So this is one method. You can directly call this x0 y0, or what is second method? You can say okay, what is y2? Y2 is equal to y1 plus 1 by 2 K1 plus K2. So if you observe, what is, we have created this formula for y2. आपण काय केले? रंज कुट्टा सेकंड ऑर्डरचा फॉर्म्युला तयार केला y2 साठी. हा y1 चा फॉर्म्युला होता बघा. y1 आपण फाइंड केला 0.1 साठी. जर y2 फाइंड करायचं असेल, y2 आपल्याला कोणाची व्हॅल्यू देणार आहे? 0.2 ची व्हॅल्यू. ओके, ऑलरेडी आपण काय केलं होतं? याला x0 y0 म्हणलं होतं आणि सेम प्रोसेसने आपण फाइंड केलं होतं. ओके, सो नाउ आपल्याला फाइंड करायचं आहे याला y2. यासाठी मी हा फॉर्म्युला आता आपण डेव्हलप करणार आहे. व्हॉट इज K1? इथे काय फॉर्म्युला? h f of x0 y0. इथे काय फॉर्म्युला असणार आहे? h f of x1 y1. व्हॉट इज your x1? Where x1 is okay. Now what is K2? K2 is equal to h f of x1 plus h y1 plus K1. Okay, where x1 is equal to 0.1 and y1 is equal to 1.0917. And by using this value, you can evaluate the K1, K2, and you can find the value of y2. Again, it will be the same value, 1.1683. So hope you understand this. Now next, so we want to stop here for today.